understood how is that we add two vectors, now let us do some problems. Let us say there is a body on which there are two forces acting. One man is pulling it by a force of 5 Newton in this direction. The other man is pulling the same body by a force of 5 Newton in this direction. By your hunch, you can conclude that this block is likely to move in this direction. What is the sum of these two vectors? We want to find the resultant of these two forces acting on the body. What is the net or resultant force acting on the body? We want to add these vectors, and because forces are vectors, they will follow the vector law of addition. How is that we are going to add these two vectors? What we have to do? I have to take the tail of one vector and shift it such that I keep it on the head of the another vector. Now this is what we have done. I have taken the tail of one and kept it on the head of another vector. These two vectors are not same. Why? Even though they have same magnitude, but they have different direction. Now the third side of the triangle will represent the sum of these two vectors, and I can say F vector will be equal to F1 plus F2. And as we can see, the sum is again in this direction. As we have assumed the body to move, the resultant vector is in the same direction. Similarly, let us say on this body a force 3 Newton acts in this direction and a force 5 Newton acts in this direction. From our hunch feeling again, the block might move in this direction, intermediate between these two forces. Let us see what is the resultant of these two forces. What we have to do? We have to take the tail of one vector and keep it on the head of another vector. This is the 3 Newton force, and on it a 4 Newton force with its tail is kept on the head of the 3 Newton force. The third side of the triangle represents the sum of these two vectors, which we know will be equal to 5 Newton. Thus, the resultant of these two forces will be a 5 Newton force acting in this direction. Next example we will discuss. Let us say there are two masses m1 equal to 2 kg, which is moving with a speed of 3 meters per second in this direction, and the another mass m2 of 1 kg, which is moving with the speed of 8 meters per second in this direction. The question is, what is the total momentum of both the masses? We know that momentum is a vector quantity, and any vector quantity will add or subtract like vector quantities. The momentum of the first particle is equal to m1 into v1 vector, which is equal to 2 into 3, which is equal to 6 kg meter per second in magnitude, and the direction is x-axis. Momentum of this. And the momentum of the second particle m2 into v2 vector is equal to 1 into 8 is equal to 8 kg meter per second, which will be in the downward direction towards negative y-axis. So these are the two vectors we want to add. Vector momentum is not a scalar quantity. The sum of these two will not be equal to 8 plus 6 is equal to 14, because they will add like vectors. And how do we add two vectors? We take the tail of one and keep it on the head of another. And the third side of the triangle will be the sum of these two vectors. The total momentum will be equal to P1 vector plus P2 vector. P1 vector has a magnitude of 6 kg meter per second, and P2 vector has a magnitude of 8 kg meter per second, and the sum of these two vectors from Pythagoras theorem will be equal to 10 kg per meter per second. Thus, the total momentum will be equal to 10 kg meter per second and not 14. And the total momentum will make an angle theta degree with the x-axis. So So this is how we are going to add vectors. Whenever there are quantities which are vector, for example velocity, force, momentum, electric field or any other quantity, we have to follow the vector law of addition. They will not add like scalar quantities.